Hello everyone, my name is Mark Lockmuller and I'm part of the Hortonworks Partner Engineering team. It is my pleasure to provide an overview of the Hortonworks data platform today. Now before we dive into the technology, it is important to understand our origin. Hortonworks was founded in 2011 by the core architects and developers that worked on Hadoop since day one. Today with over 800 employees, 1,500 partners, and 700 innovative customers, Hortonworks is one of the fastest growing enterprise software companies. Core to our growth and the value we deliver to our customers and partners is the Hortonworks data platform, a completely open multi-tenant platform for any app and any data. As we have seen the evolution of big data and Hadoop, the market has distinctly shifted from early adopters to now early majority. Today, leading enterprises from financial services, telecommunications, retail, healthcare, insurance, manufacturing, and oil and gas are adopting the Hortonworks data platform and evolving into a data-first organization. Our perspectives of the market is also backed by analyst reports. In a survey by Barclays Research, big data has shown to be one of the top 2 priorities across 100 leading enterprises in the US and Europe. As we look at the accelerated pace of market adoption, it is helpful to understand the growth and evolution of Hadoop. Independent of any technology, a key reference design for big data architecture is the Lambda architecture. The widely adopted Lambda architecture was first implemented at Twitter and promotes a layered approach to managing big data. The 3 tenets of Lambda architecture are the batch layer, where all data is stored in a cost-effective and immutable data store. The raw data is cleansed and summarized prior to being published for business analytics using the serving layer. The serving layer provides low latency ad hoc query to support business analytics, reporting, and dashboard. Complementing the batch and serving layer is the speed layer that enables real-time processing on events that require immediate action. Hadoop began its journey by serving the batch layer needs of the Lambda architecture. In its early years, Hadoop provided large internet companies a cost-effective mechanism to store all user interaction data and process them in batch for subsequent analysis using the serving layer. Rolling forward a few years, Hadoop today provides a complete platform to address the batch, serving, and speed layers of the Lambda architecture. Key to this evolution of Hadoop was an innovation called Yarn. Yarn was envisioned and led by engineers at Hortonworks, expanding Hadoop from a single workload platform to a multi-tenant, multi-workload platform that can deliver batch, interactive, and real-time data processing needs of an enterprise. Apache Hadoop of today provides shared compute and storage capabilities, enabling multiple processing engines to coexist in a single integrated environment. Having covered the growth of Hadoop, now let's look at the Hortonworks data platform built on Apache Hadoop to meet the needs of the modern enterprise. As enterprises look to onboard and expand their usage of Hadoop, they look to capabilities that span data management, data access, data governance, data security, and ease of operation. With enterprises managing sensitive data in Hadoop, it's imperative that the open community provide capabilities to meet these needs. The Hortonworks data platform offers the only enterprise Hadoop platform that delivers a rich set of capabilities across the 5 pillars of data management, data access, data governance, security, and operations using Apache Hadoop and related projects. The next sections of this presentation will cover these 5 pillars in more detail. Now that we have seen how Apache Hadoop and the Hortonworks data platform can meet the needs of the modern enterprise, let's take a closer look. In this section, we will explore key data access capabilities available within the Hortonworks data platform. Apache Hive is the most widely used SQL engine within the Hadoop community. It was created by a team at Facebook and provides a standard SQL interface to quickly access data stored in Hadoop. Hive is compatible with all major BI tools such as Tableau, Excel, MicroStrategy, and Business Objects. It is also excellent for petabyte scale batch runs. The Stinger initiative brought the Apache Hive community together to focus on speed, scale, and SQL semantic improvements for Hive. In a 13-month period, 3 phases of this initiative were delivered by 145 developers across 44 companies. Delivery highlights for Phase 1 include a new optimized ORC file format. For Phase 2, the Apache TES engine was delivered, which executes queries in memory and eliminates temporal HDFS writes between work units. And in Phase 3, a new cost-based optimizer was delivered. The Stinger initiative is definitely an example of the open community at its finest. The open community was not finished with Hive. Stinger next launched, and it also had 3 major focus areas. The first phase, already delivered in HDP 2.2, was focused on beyond read-only. This phase brought to the market ACID transaction capabilities, temporal tables, and complex join query optimization. Phase 2 of the Stinger initiative, delivered with HDP 2.3, was focused on faster SQL. This phase brought transparent data encryption, cross-site replication, and SQL performance improvements to the market. Even a new SQL editor was brought to bear for users, providing improvements in usability with visual explain and debugging. And with Apache Ambari, we now have a simplified configuration UI for administrators. The Phase 3 of the Stinger initiative, titled Sub-Second with Rich Analytics, is currently under development. The main goals are rich SQL, sub-second queries with Yarn workload management, and merge and begin and commit transaction capabilities. As you can see, the Apache Hive community is very active and committed to continually improving SQL on Hadoop. Apache Spark is a data access engine for fast, large-scale data processing. It's designed for iterative in-memory computations and interactive data mining. And Spark provides elegant, expressive multi-language APIs for Scala, Java, and Python. Spark offers Spark SQL, Spark Streaming, a machine learning library, and graphing capabilities, all running on top of a set of Spark core services, which, by the way, are enabled to run as a Yarn workload. This allows data science users to run all of these engines on a single centralized dataset on Hadoop. Spark is democratizing machine learning. Taking a deeper look at Spark ML, users can leverage unsupervised tasks such as clustering, recommendation, collaborative filtering, and dimensionality reduction. And with supervised tasks, a data scientist has access to classification and regression capabilities. Spark has an incredibly active community, and we are excited to have this as part of the Hortonworks data platform. Now let's take a look at Apache Storm, a real-time event processing engine which is also part of the Hortonworks data platform data access capabilities. Storm is ideally suited for real-time event stream processing of sensor data, which includes business activity monitoring. Storm helps an organization unlock new business cases for Hadoop and is a key component of a data lake architecture. Storm can horizontally scale to ingest millions of events per second. It also has been integrated with Apache Ambari, offering seamless configuration and management for Hadoop administrators. Let's discuss some of the key attributes of Apache Storm. First, the highly scalable horizontal architecture, when tested even on a modest 10-node cluster, was benchmarked at processing over 1,100,000 byte messages per second. Storm is fault tolerant, which means it will automatically reassign tasks from failed nodes, and Storm offers guarantees on processing, supporting at least once and in exactly once processing semantics. Storm is language agnostic, has a very active large community, and is governed as an Apache project. When organizations need to store and process petabytes of data, leveraging a flexible schema on Hadoop, Apache HBase is a particularly good choice. HBase is a high-performance, highly available distributed database on Hadoop that is ideal for low latency and read-write usage case needs. HBase is a NoSQL store. It is integrated with other HDP projects and can be managed by Apache Ambari. So what kind of applications are leveraging HBase in the market? At Salesforce, they have built a write-heavy application focused on audit and log archive. And at eBay, HBase is leveraging for HBase for search and indexing needs. At Facebook, they are building messaging applications, and Bloomberg leverages it for time series analytics. SQL is the most widely available data processing skill set in the market. We have seen that Hortonworks data platform offers HiveQL and Spark SQL already. And for SQL and HBase, Apache Phoenix is available to Hortonworks customers. It offers a SQL skin for HBase, which currently supports a large subset of SQL 1999 features. Phoenix gets you out of the one table per query model that many other NoSQL stores force you to leverage. With the Hortonworks data platform, another data access capability available to our customers is Apache Solr. Solr is an open source enterprise search capability for Hadoop. It offers high performance indexing and sub-second times over billions of documents stored in Hadoop. It is deeply integrated into the HDP stack and offers a simple, powerful UI for advanced search applications. During this presentation, we have presented multiple SQL on Hadoop options within the Hortonworks data platform. Let's take a minute to explain the strengths, which usage cases are most widely used, and share some unique aspects of each SQL on Hadoop project we have discussed. Apache Hive's strengths are it has the most comprehensive SQL, can scale to petabytes, and is the most mature SQL engine on the Hadoop market. Hive is being widely used for offloading ETL jobs from EDWs, reporting initiatives, and even large-scale aggregations. It has a robust cost-based optimizer, and it has a mature ecosystem of BI, backup, security, and replication offerings. Turning to Spark SQL, you will find its strengths are in in-memory processing and low latency usage workloads. Spark SQL is being used for exploratory analytics and dashboards, and it offers a unique language integrated query capability that is very useful for data science users. And finally, Apache Phoenix has strengths in the area of real-time read-write, transactions, and high concurrency. Usage cases with Phoenix range from dashboards to system of engagements, and even drill-down, drill-up applications. A unique capability for Phoenix would be its ability to handle real-time read-write. And with the topic of real-time engines and event processing, let's take this opportunity to compare Apache Storm and Spark Streaming. Apache Storm operates in a one-at-a-time execution model. Its strength is low latency operations, and it operates on a tuple or event stream with at least once event processing. It does support multiple languages. Spark Streaming, on the other hand, runs a micro-batch execution model. It handles high throughput needs well and operates on a stream of tuples or event batches. It supports an exactly once event processing model and also supports multiple languages. Apache Storm has proven success in the market with massive scale usage cases, while Spark Streaming is newer to the market and continues to mature. Both, again, are available within the Hortonworks platform today. We have taken a closer look at some of the data access capabilities within the Hortonworks data platform. Let's turn our attention to data governance. Apache Atlas is the only open source project created to solve the governance challenge in the open. The founding members of this project included all members of the Data Governance Initiative and others from the Hadoop community. The core functionality defined by the project includes the following: data classification, defined as create an understanding of data within Hadoop and provide a classification of this data to external and internal sources. Centralized auditing, defined as providing a framework to capture and report on access to and modifications of data within Hadoop. Search and lineage, defined as allowing predefined and ad hoc exploration of data and metadata while maintaining a history of how data source or explicit data was constructed. Security and policy engine, implement engines to protect and rationalize data access and according to compliance policy. Data lifecycle management is also important for an open enterprise Hadoop implementation. With Apache Falcon, an organization can automate the movement of processing of data sets in and out of Hadoop. Falcon offers DR, backup, and archival capabilities through replicate data sets for HDFS and Hive. Falcon also provides trigger processes for retries and handles late data arrival. Hadoop administrators, when leveraging Falcon, can set up data retention policies and even schedule and handle eviction of data. Now we will turn our attention to security and Hadoop. Hortonworks is focused on helping the community integrate open enterprise Hadoop seamlessly into existing data centers' security frameworks. So let's take a look. Security within the Hortonworks data platform is comprehensive, complete, and simple. HDP ensures comprehensive enforcement of security policies across the entire Hadoop stack. HDP also provides functionality across a complete set of security requirements, including administrative, authentication, authorization, audit, and data protection. HDP is the only solution to provide a single, simple interface for security policy definition and maintenance. Apache Ranger, a part of the Hortonworks data platform, offers centralized security for administration of Hadoop. With authentication, the community is typically leveraging Kerberos and Apache Knox. For authorization, our customers are leveraging fine-grained access controls available in Ranger. With audit, Ranger offers centralized reporting. And for data protection, wire encryption and native HDFS and partner encryption is being leveraged. Hortonworks is committed to simplifying and centralizing open enterprise Hadoop security administration, and at the same time, making sure open enterprise Hadoop plugs into existing data center security frameworks. The final area of the Hortonworks data platform that we would like to review with you today is operations. Apache Ambari is the open community tool of choice for deploying, configuring, monitoring, and managing Hadoop clusters. Apache Ambari's wizard-driven deployment templates, as well as cluster blueprint capabilities for batch deployments, offer an excellent choice for deploying Hadoop clusters. Ambari configuration UIs are very intuitive, and there is even recommendations made after configuration changes when impacts are detected to services based on change requests. Monitoring is done through dashboards, and automatic alerts are pre-configured and also customized for individual sites. Ambari has been rapidly evolving and now supports not only the operator and administrators of Hadoop, but also developers and data analysts through Ambari views. Here is an example of the Ambari Hive view, which allows developers to develop, execute, and debug queries in a user-friendly UI. Turning to CloudBreak. CloudBreak is a capability that is available to Hortonworks customers and offers streamlined one-click deployment to any cloud. It's as simple as picking a blueprint, choosing a cloud provider, and launching HDP. Here we are showing sample blueprints ranging from different needs. One is an IoT application blueprint. We have a BI analytics and data science blueprint that's been deployed, and even a dev test cluster. To complement our world-class Hortonworks support, Hortonworks SmartSense subscription is a recommendation-based automated support capability offered to our customers. With every recommendation, details of what was found versus what were recommended and the affected services and hosts are included along with a specific configuration change suggestion. SmartSense is a complimentary offer to Hortonworks support. To summarize, we are focused at Hortonworks on providing world-class data access, security, operations, governance, and integration within the open community. Thank you for taking time to learn more about the Hortonworks Data Platform, which is Open Enterprise Hadoop.